Project schedule management turns scope into a realistic timeline. It organizes work, guides resources, and reveals risks early. A good schedule improves predictability and team coordination. It sets clear expectations for stakeholders. It also supports budget control and quality. In this lecture, you will learn to identify activities, sequence tasks, and estimate durations. You will build schedules using Gantt charts and network diagrams. You will also apply critical path method and basic schedule control. Start with the work breakdown structure and break deliverables into activities. Use verbs to describe work like design interface. Ensure each activity is small, measurable, and owned. Capture outputs in an activity list and attributes. Attributes include description, assumptions, constraints, required skills, and responsible owner. Link each activity to its deliverable. Validate completeness with the team. Ask what must finish before this can start. This seeds sequencing later. Keep names consistent for easy tracking. Use the precedence diagramming method to order activities. Identify logical dependencies and record leads or lags. Common relationship types include finish to start, FS, task B starts after task A finishes, start to start, SS, task B starts when task A starts, finish to finish, FF, task B finishes when task A finishes, start to finish, SF, task B finishes after task A starts. Confirm external dependencies like vendor deliveries. Note mandatory versus discretionary links to support later optimization. Lay activities on sticky notes or a whiteboard. Ask the team to arrange them by logical flow. Add arrows to show dependencies and lags. Validate paths from project start to finish. Check for circular links and fix them. Consolidate the sequence in your scheduling tool. Record assumptions behind each dependency. Keep the diagram readable. Group activities by phase or deliverable to reduce clutter. Review with stakeholders for alignment and missing steps. Choose estimation techniques that fit your data and risk. Useful methods include expert judgment from people who have done similar work, analogous estimates based on past projects, parametric estimates using rates like hours per feature, 3-point estimates, optimistic, most likely pessimistic. Consider calendars, working days, and holidays. Factor in risks and learning curves. Document assumptions and estimation ranges. Use buffers intentionally, not everywhere. 3-point estimating is a project management technique used to create more realistic activity duration or cost estimates by considering uncertainty. Instead of relying on a single guess, it uses 3 scenarios. Optimistic O, the best case scenario if everything goes smoothly. Most likely M, the realistic scenario based on normal conditions. Pessimistic P, the worst case scenario if things go wrong. From these, you calculate an expected estimate using formula. PERT weighted average, O plus 4M plus P divided by 6. This reduces bias, captures uncertainty, and improves schedule and cost reliability. Define resources for each activity, people, equipment, and materials. Clarify required skills and availability using resource calendars. Distinguish effort from duration. 5 days of effort can span 2 or more weeks. Identify bottlenecks, like a shared specialist. Plan for onboarding, time and context switching. Use resource loading to see overallocations. Apply resource leveling to fix overloads by delaying work. Use smoothing to even peaks without changing deadlines. The critical path is the longest sequence of dependent activities in a project that determines the shortest possible completion time. If any task on this path is delayed, the whole project is delayed. Tasks on the critical path have zero float, no flexibility. The critical path method, CPM, is the project scheduling technique used to identify and manage the critical path. Usually, software like MS Project will calculate CPM for you. A Gantt chart displays activities as time-scaled bars. It shows start and finish dates, durations, and dependencies. Steps to build, enter activities and durations. Add dependencies and lags. Assign resources and calendars. Mark milestones with 0 duration. Set a schedule baseline for control. Use grouping and color for clarity. Review the critical path and near critical activities. Update progress regularly to keep it useful. Network diagrams visualize task logic without a calendar. Activity on Node uses boxes for activities and arrows for dependencies. They help detect missing links and parallel opportunities. Build from left to right, start to finish. Include durations on nodes to support CPM. Mark external starts and finishes clearly. Keep the diagram simple and readable. Use it alongside the Gantt chart. It is your map for scheduled math and risk discussion. CPM finds the longest path through the network. That path defines the shortest possible project duration. Activities on the critical path have zero total float. Steps: forward pass computes, early start and early finish. Backward pass computes, late start and late finish. Float equals late start minus early start. Watch near critical paths with small float. Shorten the schedule by reducing durations on the critical path only. A baseline is the approved version of a plan, scope, schedule, or cost that serves as a reference point for tracking and measuring project performance. Scope baseline defines what work is included, requirements, WBS, deliverables. Schedule baseline, the approved project timeline with start/finish dates. Cost baseline, the approved budget over time. Once set, the baseline is only changed through formal change control. By comparing actual performance versus baseline, project managers can see if the project is on track, ahead, or behind. Think of it as the original roadmap against which all progress is measured. In order to control the schedule and keeping it on track, first set schedule baseline for the approved schedule. Then track actual starts, finishes, and remaining durations. Compare baseline and actual to find variance. Helpful metrics include schedule variance SV and schedule performance index SPI. Milestone slip reports and trend lines. Respond with fast tracking, which overlaps tasks, or crashing, which adds resources. Assess risks before applying changes. Use change control to update the baseline. Avoid vague activities like do testing. Define done criteria. Do not ignore resource calendars. Watch near critical paths, not just the critical path. Keep assumptions visible and reviewed. Limit discretionary links that block flexibility. Update remaining durations, not just percent complete. Meet weekly to review risks and dependencies. Use milestones to signal progress. Keep the schedule simple enough to maintain. A simple current schedule beats a complex, outdated one.